So welcome everybody to this splinter session on the US Extremely Large Telescope program. We plan to get you very excited about the program and also to give you a couple of updates on the 30-meter telescope project and also on the Giant Magellan Telescope project. So we'll have a couple of presentations. After each presentation, we will have 5 minutes for questions. Please use the Splinter Slack channel, which is called US Extremely Large Telescope Program. So this is where you can write your question and I will relay them to the speaker. After all of the presentation, we will have something around 10 or 15 minutes for discussion when we can continue our own question, and also everybody are welcome to provide comments. We will open, I think there is no too many traffic, this for direct discussion through the Zoom. We see how things goes. So our first presentation will be by Pat McCarthy from NOIRLab, and this is about building a unique capability for the US community. So Pat, if you're ready.
And just to comment, the Slack channel is given there on the slide that you see in front of you. So please join the Slack channel, Splinter the US Extremely Large Telescope program in order to ask questions.
Very good. So thank you, Marie. Yes, and thank you, Mark, for clarifying. And for those who might be Slack challenged like me, this one's not under the numbered Slack channels, it's under the splinters, as Mark just explained. So let's get started. Let's see if I can get control here. So I'm going to start out with a little bit of an introduction, talk about the unique capabilities that the US Extremely Large Telescope program will bring to the US community. But just to remind everyone of what the agenda is, following this brief introduction, Mark Dickinson will talk about how the work that NOIRLab will do in building software and providing user support will enable transformative community research. Then Darren Norman will talk about how we intend to use big data and big data tools to allow underrepresented groups to engage in research with the largest telescopes in the world. Really how we can use this data to build a more inclusive research community. We'll then hear from the two project leaders. We'll hear from Feng-Xuan Liu and Jim Fanson, the project managers for the two projects. I'm not sure I've got the order right, but they know how they're going to do this, and they'll tell us where those projects are from a technical and programmatic point of view. And then I believe we'll have open time for Q&A for the whole enterprise, as well as some Q&A after each talk. So let me just remind people of what we're trying to accomplish. The idea is we want to build a bi-hemispheric system of extremely large telescopes. With a 30-meter telescope in the north and the Giant Magellan Telescope in the south, we'll have an unprecedented capability. Having this two telescope bi-hemispheric system brings a lot of advantages. Obviously, there's full sky coverage that allows one to look at rare objects, to do work that requires the full sky or requires the two telescopes look at the same target, for example, the galactic center at the same time. By having more ports, we can have more instruments and optimize and put more powerful instruments on each telescope. And to avoid then costly duplication, we can use each telescope, its optical configuration, its site to its maximal advantage by optimizing this as a system. And of course, having two telescopes means there's more nights on the sky. We expect these two telescopes to be very heavily oversubscribed, comparable to what we see, say, with the Hubble Space Telescope or other unique assets. So the demand, we believe, will be very large, and having more access will simply mean more science can get done and more ideas can be brought to the table and more scientists can participate. The science capabilities we think are really quite remarkable. One way to think about it just in terms of raw sensitivity, as you know, the Rubin Observatory will come online in the next few years, and that will be followed then by ESA's Euclid mission and the US NASA Roman Infrared Survey Telescope. And together they will produce an unprecedented multicolored map of the sky to extraordinary depths and over very large areas. The ELTs will bring us the capability to get a spectra or a redshift or diagnostic information for any target in those imaging surveys. And that's a remarkable capability. We haven't had that capability before. The extraordinary angular resolution that comes with adaptive optics on the extremely large telescopes will allow us, for example, to probe crowded stellar populations with 10 milli-arcsecond resolution. This simulation shows a crowded field as imaged with the Hubble Space Telescope of the infrared, and then as it would look with an ELT at that 10 milli-arcsecond resolution. You can see the remarkable power of the large apertures, particularly in crowded fields. And of course, the Webb Space Telescope will be somewhere in between those two in terms of angular resolution. Another place where this is very powerful is in studying the properties of black holes. I'm showing a simulation, actually reality of state-of-the-art with the Keck Observatory in the black hole at the center of the Milky Way, and then a simulation of how it will look with an ELT. So you can see what people are doing now that's led to remarkable science, and then the extraordinary capability that comes in these highly confused regions. And the fact that the GMT being located at minus 30 degrees means the galactic center goes right overhead, and having that two telescope capability to bring different instruments to bear will be important. But beyond the galactic center, the ELTs will allow us to probe black holes in other galaxies, allow us to push down the mass function in nearby galaxies, and then probe the upper end of the mass function over very large volumes. As we saw in Sandy Faber's gold medal lecture this morning, black holes play a critical role in regulating star formation in galaxies, and the more we can probe their mass function and their properties, the better we'll understand not only black holes, but galaxy formation and evolution. Closer to home, the ELTs will really open up new discovery space in the study of exoplanets. I'm showing here a simulation of a planet around a star as viewed with the Gemini Planet Imager, and now how it will be seen with the ELTs. So not only do we get a smaller inner working angle, greater image concentration, greater sensitivity that produces an enormous return, goes as a high power of the aperture, and really will bring exoplanet imaging to a whole new regime. So we've been talking about the scientific potential of these telescopes literally for more than 20 years now. So I think the case is really quite compelling scientifically. Now we should talk about some of the more interesting scientific societal impacts and how we might bring all this about. So the question I pose here is, what would a federal investment in GMT and TMT bring? Should the decadal survey recommend such a course, and should that turn out to be feasible? We're targeting a share of the observing time of at least 25% to the community, perhaps as large as 50%. But beyond that, the community would have a role in governance and a role in decision-making. They would have one or more seats on the board of directors. They would have seats on the scientific advisory committees that would give them a voice in the selection of scientific instruments and directions, say for adaptive optics, and an opportunity to participate in or even lead the development and construction of technical components like instruments and AO systems. In a broader sense, this brings the community a proper seat at the table on the largest apertures in the US, a real equity position. And this is actually a first for US astronomy, because the largest telescopes on the ground at any one particular time have never really been fully operated with the US community as an equity partner. And we think this could actually be a major step forward for US astronomy. So what will NOIRLab bring to the table as part of our role in this partnership? As you'll hear from Art, we intend to produce easy to use phase 1 and phase 2 proposal tools. We'll have a common interface, so users won't have to learn, how do I propose for GMT or how do I propose for TMT? They will look the same. And our expectation is they will look very similar to the interface used for Gemini at that time. So we'll have a very common portal, and that interface will connect to all the relevant data one might need to write your proposal or your phase 2. That is Rubin's legacy survey of space and time, the dark energy survey, other databases that are critical to helping you prepare your observations and make them the most impactful. We will produce and steward high quality data pipelines so that your data will be transformed into something you can use to do your science. You won't have to be a specialist in every instrument. And then all of the data will be archived, and the US will have access to all of the data from both telescopes. And as we're seeing now, archival research, as it's called, is just as powerful, and it happens just as frequently as classical research. And so this is a very powerful capability. The idea is that we wish to provide support for every user from idea to publication. That is, if you've got an idea, we'll help you ensure you can write a proper proposal. Your proposal is reviewed. You get data, your data is turned into science, your science is turned into a publication. What else would federal investment buy? In essence, it will level the playing field across the US. That means anyone at any institution will have a fair chance to bring her or his idea to the table and have it reviewed without any bias. Large key projects that might be used, say, to probe the properties of dark energy or dark matter or conduct a census of planetary systems, those key projects would be open collaborations. Anyone with an interest in the skill can participate in them. And this vision we have for a bi-hemispheric system would put the US in a unique place of having that ELT capability anywhere in the sky, essentially at any time. This means that anyone in the US or our partner community who has an idea can conduct large telescope science in a completely competitive manner. And it's no longer the case that one has to be at a special or privileged institution to do really big science with the big telescopes. Anyone with a good idea has a fair shot. And so we see this as a way to move US astronomy into a more inclusive culture. And really, ultimately, it gives more opportunities for ideas to flourish, and that will make the science go faster and certainly make it better in the long run.
At 1 minute.
Yes, thank you. So just to wrap this introduction up, what are we talking about? The possibilities that a US investment would create. So it's open access to ELTs, north and south, and with a time coverage for those interested in time domain astronomy of about 15 hours. State-of-the-art instruments and adaptive optics systems that the community can not only use, but participate in their development. Powerful data archives and tools to probe those archives. New discovery space in a variety of scientific areas. Strong synergies with space astronomy, particularly with Webb, Rubin, and Roman. And support system that is, I think as Sidney Wolf said it best, it's a support system that's appropriate to an investment of this size, to bring the same level of software and user support that we're used to in space missions to the ground so we can get the best return on this potentially very large investment. So with that, I will hand it back to Marie, who will manage this, and then turn it back over to Mark when the time is ready.
Thank you very much, Pat. So we have 5 minutes right now for questions. I do not see anything in the Splinter Slack channel right now. Let's give it a couple of seconds to see. Okay, so I propose that we move on and we can still go back to ask some question to Pat during the discussion. So the next presentation will be by Mark Dickinson from NOIRLab also, and Mark is going to give us more detail on the US Extremely Large Telescope Program user service and showing us how to enable transformational community research. Mark, you ready?
Good.
Wonderful.
Let's see. Am I ready? Are you seeing my slides?
Yes, thank you.
Very good. All right. Well, thank you. And thank you everyone here for joining us today. As Marie and Pat said, I'm going to be talking about NOIRLab's role in the US ELT program and how we will be going about providing user services to the US astronomical research community to enable transformational community research. Some of the guiding principles for the US ELT program and that are guiding our activities at NOIRLab as we're in the development phase for US ELTP are, well, of course, to enable transformational science through US access to a bi-hemispheric ELT system, as Pat described, to enable and support large-scale systematic collaborative research, what we're calling key science programs. If you've been to some of our open house and AAS sessions in previous years, you've heard about some of the ideas for key science programs. I'll touch on that very briefly But for most part, I'm going to focus on the services that will enable those key science programs and other research. We're going to provide outstanding user support commensurate with the proposed investment in the USELT program. And as Pat described, to broaden participation in science with these powerful observatories and to foster research inclusivity. Darren Norman will be discussing that after me. And finally, to engage and represent the whole US community in the governance, scientific planning, and instrumentation development for GMT and TMT. So all US astronomers should benefit from national participation in a US ELT program. The key science programs that I was mentioning will provide scientific legacy through systematic investment in large-scale transformative research using TMT and GMT. And the US national community will have the largest partner share in these observatories. And as such, this share will enable projects to be carried out on scales that would be difficult to realize within the current GMT and TMT partner shares. At least half of the US ELT time we envision would be dedicated to key science programs. That's of course up to the community to decide ultimately, but that's our model that we're working with as we develop our plans. And that would correspond to more than 80 nights per year for GMT and TMT combined. There would be broad, inclusive scientist participation in the KSPs via open collaboration models to harness the resources of a diverse research community and to spread the benefits of the US ELT program widely through the community. As has been shown from large survey programs on NOIRLab's existing telescopes, on Gemini, and from Hubble's, and from space observatories in general, the data products from these large coherent projects tend to have high archival reuse value. They're data that can be used by many people for many things. And so that's another merit of this KSP idea. But in addition, we would also be reserving time for smaller, more PI class, what we call discovery science programs. Those would be allocated on a more regular cadence, and they would be nimble and responsive to new discoveries and new ideas as they come along. And a couple of years ago, we had a community-based effort to develop concepts for key science programs. Actual future key science programs would be selected by peer review, but these concepts are helping us to, as use cases for the development of our plans for user services and to set the science requirements for these services. And they span the whole range of science from exoplanets to cosmology to supermassive black holes and gravitational waves to resolving the physics of galaxy evolution and many more topics. So NOIRLab, the role of NOIRLab in the USELT program is to provide end-to-end user support. And some of the user services that we are envisioning include, well, allocation of observing time on TMT and GMT for the community, observation management, queue scheduling system, I'll discuss that, data management and archiving, data reduction and calibration systems, data analysis tools, and documentation, training, and help desks. Now, fortunately, we have experience in all of these areas within NOIRLab and within the programs in NOIRLab, from KitPeak, CTIO, Gemini, and into the Rubin era. We've done these things before. In many cases, these are efforts that are undergoing modernization now, particularly at Gemini with their phase 1 and phase 2 system, now called the Gemini Program Platform. There was a webinar, I believe it was on Monday about that. Maybe you heard about it, the queue scheduling system. All of these things are things that NOIRLab has done for decades and has much experience with. And we'll be building from that experience in order to build the USELT program. And if you're interested in the existing precursor systems, please go by the NOIRLab booth in the NSF Pavilion, and you can talk to people about these things. The user support tools that we build for the USELT program will be available to the US national community and to the partners in TMT and GMT, the existing partners from institutions in the US and the international partners. So let's run through some of these. Observing time allocation. So TMT and GMT will be open to any US astronomer with a great idea. Be able to apply for either or both observatories and for other telescopes offered through the NOIRLab system through a single proposal process. We'll be implementing a peer review process designed to mitigate conflicts of interest and implicit bias. This is an effort that's already well underway within the NOIRLab time allocation process now, and we'll be carrying that further with USELTP. It will support both PI class discovery science programs and large-scale key science programs. We'll be tracking projects from submission all the way through the archival data products they produce, and we'll be engaging the community to support the development of the key science programs and organization of broad inclusive research teams. Observation management, as Pat described it, one of our aims is, TMT and GMT are different observatories, but we want to provide a uniform community interface to both, so it's straightforward for community astronomers to work with both telescopes, either independently or together. So the phase 1 proposal process and phase 2 observation preparation systems would integrate tools to evaluate exposure time, identify guide stars and the like, and they'd be designed to support and assist new users, not just the insiders and experts who are already intimately familiar with these telescopes. We'll also be developing dynamic adaptive scheduling systems for TMT and GMT. These would accommodate queue or service mode observations, cloud visitor modes, or any other modes that are required by the community and by the observatories. The queue scheduling systems would assemble observations into a prioritized queue based on target visibility, atmospheric conditions, timing constraints, etc. It would be flexible and responsive to changing conditions and constraints, accommodate interrupts such as target of opportunity observations, and enable coordinated observations involving both TMT and GMT or either observatory with other NOIRLab telescopes. Data management and archiving. So all TMT and GMT data from all of the partners in those observatories will be archived and available for US community research. We'll be handling data transfer from the observatories to NOIRLab's archives, archiving the data and distribution of the data for all data taken with TMT and GMT. We'll be archiving raw, calibrated, and reduced data, high-level science products from the key science programs. We'll have full implementation of proprietary controls. A standard proprietary period will probably be 18 months for data with these telescopes. The data will be discoverable and accessible after the proprietary periods end, and we will provide the long-term archiving and stewardship for the data from the USELT program. Our archives will be integrated with other data systems, both the TMT and GMT data management, the automated calibration and pipeline execution. I'll discuss that in a moment. The data science suite, another thing I'll discuss in a moment, and DOI generation and publication tracking based on the data in the archive. So removing barriers to carrying out research with these data is very important to the USELT program. The instruments on TMT and GMT, in some cases, will be complex and will have many modes. They'll produce complex data sets, particularly integral field spectrometers, producing data cubes in a variety of formats, different spaxel scales, different modes, different resolutions. And working with these data may be complex. So the pipelines to process data from these instruments will be provided by the instrument teams, the experts who are building the instruments and know the data best. And those pipelines will be deployed in a stable NOIRLab software environment. We'll operate those pipelines to produce and archive reduced calibrated data products. But also external users will be able to access and operate the pipelines on the NOIRLab platform. So if you want to process data independently or make different choices than whatever the standard data reduction that we'll be carrying out is, you can do that, and you'll be able to learn how to work with the data and with the pipelines yourself on our platform. And we'll be collaborating with the GMT and TMT teams and with the scientific community on further evolution of the pipelines. Data analysis tools. It's been amply demonstrated that outstanding support for data analysis enhances the scientific productivity of an observatory. And so we'll be providing a suite of data analysis tools basing on the sort of science platform model that is now increasingly popular and is used in the Astro Data Lab at NOIRLab, that will be part of the Rubin Science platform, but extended to the types of data and the types of instruments that are available at TMT and GMT. These data analysis tools will provide high-level visualization and analysis tools, interactive notebook environments for working with the data, a common software stack, astronomical software that will be available to users in this environment, catalog query capabilities, support for collaborations, user-driven publication capabilities, so people will be able to essentially publish not the papers, but the data sets behind their research and make them available to others. And this will be integrated with other NOIRLab data holdings and services, so that data from TMT and GMT can be placed into context, say, for in the context of the Rubin LSST data or the other data sets that are available. So NOIRLab will be supporting US astronomers in the global ELT era. US community access to forefront bihemispheric observatory, optical infrared observatories has really been central to the mission of the National Observatory for more than 50 years. And we'll be building US ELT support services based on decades of experience at NOIRLab. Outstanding user support from the proposal to the publication process enhances scientific productivity. That's our belief in any case. And we'll be carrying these principles into the global ELT era, providing access for all US astronomers to these observatories, minimizing barriers for community use of the telescopes and their data, and broadening participation in research with TMT and GMT. So please stay tuned. We are just now really entering the development phase for these services. We're scoping out use cases and science requirements for them, and we're going to be asking for your help and your input on this process this year. So look out in our newsletters and Currents electronic newsletter for opportunities to participate in this process. We want to make these telescopes the best they can be for you and the services that we provide. And that's why we'll be asking for your input. Thank you very much.
Thank you very much, Mark. So we have time for our 5 minutes question, and I'm seeing that there is actually 2 questions in the Splinter Slack channel. The first one is from Justin Spilker. So Justin is asking if PIs at TMT or GMT member institutions will be able to get time through the US community poll. Will that be possible for them?
Yes, scientists at US institutions that are partners in TMT and GMT will be eligible to propose for open access time through NOIRLab as well.
Thank you, Mark. So the second question is from John Tobin, and John is asking if, with the open collaboration concept, will proposal team from the Key Science Project be compelled to accept new members to their teams? His concern is that the observatory may be imposing a governance onto how science is done and how teams are formed.
Well, there's a lot of work to be done to understand how the open collaboration models would work. And there's a lot of experience now with this in other collaborations. So it's time off before we're to the point where observations will be starting with these observatories. So we have time to work with the community to develop the ideas behind these open collaboration models. And it may not be a one-size-fits-all scenario. I don't think compelled is exactly the way I would put it. I think people will be participating in collaborations because they can contribute something to those collaborations, and in the kinds of models that have been followed by Sloan and other collaborations, there are usually agreements made for what people will contribute in response for participating in these in the collaborations.
Okay, thank you, Mark. So we have one question. I think this was, thanks Ryan for sending it to the right Slack channel. So I think this is from Lisa Wells, and she's asking, with the huge number of transients being discovered just today, and also the advent of the LSST, will there be a maximum amount of time allocated to the target of opportunities per night, such that they will not dominate the ELT time over PI programs or even the KSP?
I certainly couldn't answer that question right now. I think, you know, it's certainly true that once the fire hose starts from LSST, the amount of observing time needed to follow up everything interesting will be tremendous. So I think it's going to be up to, you know, essentially the community decide how it wants to use these facilities. There may be a limit on how many, maybe practical limits as to how many target of opportunity responses any observatory can do in a given amount of time. But we wouldn't limit it based on policy, I don't think. We'd have to limit it based on demand and practicality.
Thank you, Mark. I do not see any more questions, but let's wait a couple of seconds and see if anyone has some question or thought right now for Mark. Okay, so I see nothing. So let's move on. Thanks again, Mark. So our next talk will be by Dara Norman from NOIRLab. And Dara is going to talk to us about the US Extremely Large Telescope Program Research Inclusion Initiative. Okay, we can see your presentation, Dara.
Great, I just have to find the mic now, it moved. All right, thank you all for being here. I am going to start my clock. And I'm here to talk about the US ELTP Research and Inclusion Initiative. And I'm going to do one thing because right now I can't see my slides very well. There, that's better. Okay, the Research and Inclusion Initiative. And so I'm going to start off with why do we need a US ELTP Research Inclusion Initiative? And as Mark said, and as others have mentioned, we really want to support research participation from the broadest US community of users. And this specifically means addressing some of the concerns of researchers at small and underserved institutions to be able to participate in the US ELTP, and particularly in the key science programs. So how are we going to do this? We really want to make research inclusion part of the culture of how we're doing science. And so we want to focus on 4 main areas of inclusion identified through conversations with researchers at small and underserved colleges and universities. Now, I'm not at a small college or university doing work, but and so I reached out to talk to folks at those places to ask them, what are the things that keep you from being involved in these kinds of collaborations? What are the things that you would need to be involved in these collaborations? And the 4 things here are things that they most often mention to me: policies and procedures that support mutually beneficial partnerships, opportunities for scientific networking and collaboration building, technical infrastructure that enables participation, and opportunities for being trained on science platforms and tools. And I'm going to talk about each of these 4 main areas in turn in the rest of this talk. Although I'm not going to talk about them in the order that they were presented. So I'm going to start with the idea of data access and user support. So we at NOIRLab have a lot of expertise in data access and user support. And we want to really build up the opportunities for inclusion through this data access. So we have technical infrastructure now, and we will be using that expertise to move it to how we support the US ELTs. Technical infrastructure to support access and enable broad participation. Through archives, as Pat mentioned, archival science is a really important part of how science is done, but we also want to enable opportunities for folks to understand how to use those archives and how to use the tools and services that we're building to support those getting data on those archives. So examples from right now in the NOIRLab program are, for instance, the Astro Data Lab as a science platform, and our archives at NOIRLab. The other thing we are going to be doing as part of the Research Inclusion Initiative is promoting opportunities to train folks on these scientific platforms and with these tools. And we want to do this for researchers at all career stages. So we have experience with supporting schools, for instance, the La Serena School for Data Science, as well as supporting folks who have other schools contributing speakers and expertise to those schools. But we're also branching out into other ways that we can support folks who maybe don't have time to go to schools or don't have the travel funds to go, by having online opportunities for training. And here I've highlighted down here the Antares project, where they have online training tools, both in Jupyter notebooks, but also they've put these tutorials online in YouTube. And so we're going to be exploring all of these different ways to support training. We also are really, it's really important to us to broaden participation for all scientists. So we're going to be focusing on activities that prepare the community for inclusive policies and practices to support networking and collaboration. And we have a really extensive experience at NOIRLab with supporting opportunities at meetings and at workshops for building networks and collaborations. Mark talked about this workshop to develop science as part of the key possible future science for the key science program. And we want to do more of these and more opportunities for folks at small and underserved institutions to be involved in advising us on how we can best collaborate, do collaborations, and help support them in being able to join some of these collaborations. The other thing we want to do is build policies and procedures that support mutually beneficial partnerships. And we've talked a little bit about the ideas of open collaboration, but also looking at policies for allocation of time on the telescope. And that's what I'm going to talk about in this next slide. So we want to support time allocation in that we are valuing inclusion as part of how we do science, as part of the scientific merit of the science that we're proposing. And so we are going to incentivize formal institutional change that promotes research inclusion. We want to look at, we want to reward folks for doing science in a collaborative and an inclusive way, alongside of what kind of science they are doing. We are discussing a requirement for research inclusion component in the time allocation of proposals, particularly for the key science program. And this research inclusion component will be reviewed as part of the scientific merit of the proposals, alongside the science that you're doing, and also alongside things like the data management of these large programs, which you would also have to explain how you're going to get the products and data from those science programs out to the public. The way that we're doing this is that we want to help prepare the community for this. And so we've received some NSF developmental funding to prepare the community to be able to write these inclusive components of their proposals. So what we're doing right now is we're building a toolkit of inclusive collaboratory practice as a guide, and we're going to seed that toolkit with some of the things that folks are already doing in the community, some of the practices that are going on right now in the community to be more inclusive in collaborations. We're going to provide information and look into the efficacy of some of these practices in order for folks to understand what metrics they should be collecting to assess how well they're doing on these collaboratory efforts. We're going to provide recommendations and guidelines for the assessment of proposals that are put in, and research inclusion practices. And we're going to recommend policies for long-term observational programs to report back on those metrics that they put in their proposals in order to demonstrate that they really are executing on the inclusive practice that they proposed in their proposal. And so I'm really excited about the fact that we have this funding. And right now we're in the late stages of hiring a postdoc to help support this effort. So this is my last slide. And what I want to say is that we are the research inclusion initiative is really about the culture of how we do science, the values we bring, the norms that we expect of people, and and in making traditions that are really inclusive for the US ELT TP. So as I mentioned, we're going to focus on these 4 main areas. And what I want to leave you with is that already NOIRLab has the expertise to really support this culture changing effort. And I'm happy to take any questions that people have.
Thank you very much, Dara. So yes, time for question. Okay, I just see one that just came from Tane Curry. So she's saying, so TMT has invested significantly in a workforce pipeline and education in Hawaii and gave UH a share of observing time. What are GMT's plans on this nature? In general, how will NOIRLab NSF involvement advance equity for communities most affected by the observatory, not just mainland astronomers who have no personal connection to Hawaii or Chile?
So that was quite a long question.
Yes.
And and right now, the US ELTP Research Inclusion Initiative is really the way I've envisioned it and putting it together is it's designed to speak to the areas in which NOIRLab is actually supporting the 2 telescopes to provide access to the US community. I can't speak for TMT or GMT individually as projects about what other kinds of inclusion initiatives they might be taking, but I hope that in the in the Slack folks who are more aware of what those telescope projects might be doing can answer that. For NOIRLab, the area that we are really engaged in with this program is in the data services in the opportunities to make data access and opportunities on the telescopes equitable for the largest community in the US.
Thank you, Dara. So yes, actually, Tane, we will go back to this during the discussion, and we'll give opportunity to TMTs and GMT representatives to comment on that. Any other question for Dara? Going to wait a bit. Okay, so we have a question from Lisa Wells. She's asking, can you elaborate on the La Cenera Data School and give more information about who will benefit from this?
So the La Serena Data School is actually, they're accepting applications right now. And if you go to the NOIRLab booth, you can actually find out more about the school. The school is actually intended for students. They're mostly students in their early career of graduate school, or there are a few students who are accepted who are late stage undergraduate for that particular program. It is in La Serena, and La Serena, Chile, usually, and it usually happens in August. Now, because of the pandemic, we had to cancel it for the last year. We canceled the whole thing for last year because we didn't know what was going to happen. This year, it is going to be an online school, and we're preparing for just exactly how that is going to work right now. But it concentrates on data science and opportunities and tools for how to do great science with large data sets.
Thank you, Dara. So don't see anything else. So let's move on. Thank you again, Dara. So our next presentation is by Fen Xuan Liu. Is going to give us an update on the 30-meter telescope project.
Okay, can you hear me or
Yes.
see my screen?
Yes.
Okay, good. This is Fen Xuan Liu. I'm the project manager acting. I was the deputy project manager. Our longtime project manager, Gary Sanders, retired in December. So the TMT system architect is Richie Krishan design, and the primary, let me get rid of this screen. So primary mirror has 492 segments, and the secondary mirror is a 3.1 meter convex, and the tertiary mirror is a flat of 2.5 by 3.5 meter. This gives a, oops, I'm having trouble forward. Okay, so this gives a 20 arc-minute field of view or 15 arc-minute M-vigneted. So TMT partnership is a global public-private one, and the private fundings come in all cash formats from the University of California system and Caltech, thanks to large contributions from the Gordon and Betty Moore Foundation. And the public funds in both cash and in-kind contribution come from the government of Japan, India, Canada, and China. And as part of the USELT program, NSF and our as a potential partner. So the project organization is staffed with all experienced team members, and this has been in place for a while, and shows clear lines of authority and communication paths. We've been using operating under the project control for a few years, and this includes signed work packages for all cash funded or in-kind funded tasks. We use a simplified version of earned value management to measure performance and to identify issues early, and it's been quite useful. After over decades of effort by our team, all enabling technologies are enhanced, and this includes the segmented primary mirror system architecture with associated alignment and facing system. And these were based on Keck heritage with improvements in TMT made. And some of these improvement features have been implemented and tested out on Keck. And so it's been a very good win-win collaboration with Keck. The multi-conjugate AO system is called Nefarious instrument, and it's led by experienced individuals from prior large telescopic systems, AO systems, and the key elements such as the deformable mirrors or real-time controllers are in fabrication. And other key elements such as the high order detectors and lasers are commercial off-the-shelf items with proven reliability. So the overall system design is mature as measured by cost. 82% of the total system is in final design or in various stages of production. A few examples of major subsystems. Enclosure is ready for fabrication. This is a responsibility of Canada's Dynamic Structure Incorporated, and it passed all the design reviews and production readiness reviews, and it's based on extensive analysis, modeling, simulation, and prototyping. The telescope structure is responsibility of Japan's Mitsubishi Electric Corporation, and it's also ready for fabrication. It passed all design reviews, and the first production readiness review focused on line lead items. And it also relied on extensive analysis, modeling, prototyping. Some of them are shown here. The primary mirror segments are in production. On the left is a fully assembled one. On the right, it shows rings of 4 countries involved. In the middle ring the segments come from Japan, and outwards is US, followed by India and China at the outskirts. Japan is leading the overall activity, as O'Hara Corporation delivered 62% of all the blanks, and that's enough for 4 years of polishing and or filling 24 meters aperture with spares. And the Canon Corporation had polished 30 roundels, and the Shiba Corporation has started hex cutting, and shown on the right. Oops. US is closely behind. The Coherent Corporation Bay Area is under firm fixed price contract for polishing and for hex cutting. Shown here are some of the facilities and team and the blanks and machinery. On the right, it shows Arizona Optical System AOS is completing the final metrology system. For us, this is based on computer-generated holograms. Oops, I have trouble with forwarding. Okay, in our laboratory near Pasadena, we have built a multi-segment integration test facility, and it's to test assembly in installation procedures or control elements and risk reductions. And in the middle, it shows 7 segments installed with aluminum mirror, dummy mirrors. On the right, it shows a gap between 2 segments of 2.5 millimeters. The AO system multi-conjugate instrument, the Ferris, is responsibility of Canada. It's also ready for fabrication at National Research Council, Canada. It passes design reviews and optics fabrication readiness review. And it has large performance margins supported by extensive analysis, modeling, simulation, prototyping. Outside of the TMT cost book, thanks to Canadian government invested in this large integration test facilities, and the first user will be Nefarious. And in the middle here, you can see a digital mock-up of Nefarious instrument with the IRIS science instrument attached at the bottom, and it shows the scale of the facility. Speaking of IRIS, it's the infrared imaging spectrograph, and it's completing its final design in May of this year. Shown here are a lot of the prototype elements, and that's being tested in the laboratory. It's worth pointing out that IRIS will be integrated with Nefarious and fully tested out in Canada before shipping to the site, so we should know how it performs. Another AO-fed diffraction limiter instrument is MODIS, and it was selected lately in 2019 to enhance TMT's exoplanet capability. And it's a single mode fiber fed diffraction limited spectrograph. Because the size is independent of the telescope aperture, we can realize more heritage from similar efforts. In fact, the same team built and delivered the PARVI instrument and is currently operating in Palomar, and this, an upgraded version of that instrument is being considered for Keck. At first light, a seeing limited instrument is a wide field optical spectrograph. And in 2018, this instrument went through a total complete thorough design optimization, including on-axis field of view, efficient layout, gravity invariant configuration, and all of these reduce complexity and overall cost. And the team is redoing the conceptual design, should be complete in May of this year. Observatory software, it's all designed in US by TIO here and implemented and fabricated in India. And common software has already been delivered, and it's enabling other part of the TMT software development. It's a backbone. Executive software, the next layer, is finishing its final design review this year. And to maintain the quality and uniformity, we have a software test integration laboratory still that's running in Pasadena, and all TMT software will be tested and verified on this still. So change gear to the site. Our preferred site is Mauna Kea. We have all the permits and all the contracts are lined up and are shovel ready. But as you all know, we have issues accessing the site. As a result, we have an alternative site, ORM in La Palma. And there we'll also have all the permits and contractors lined up and ready to go in case the decision is made. So in summary, TMT technical maturity is high. We are people ready, process ready, shovel ready, pending the site access. The partnership, meanwhile, is working very hard to advance the design and fabrication. And we're very excited to be part of the US ELT program, leveraging our existing partnership to offer US astronomy community full sky access for extraordinary future in optical IR astronomy for all the reasons that's been mentioned by previous speakers. So thank you. I'll be ready for questions.
Thank you. Thanks a lot. Thanks, Juan. So now we're going to open for question on the TMT project. So we have a question from Alex with she's asking, what is the time frame for which a site selection decision needs to be made?
That's a complex question, and I think the next indication is we're looking for guidance from Astro 2020 report, and we'll evaluate that and move forward from there.
Thank you. I'm seeing someone typing something, so let's wait a bit. Okay, so can you give us an update on what's going on right now in TMT for engaging the local communities? Any update on that?
Yes, we have multiple channels, and the activities led our board and various members of the board, and we have a committee called the Hawaii Engagement Committee, and it deals with communication as well. And so I don't have a whole lot of details to go over here, but we are thinking and consulting with all our sister observatories on the island and trying to figure out all ways that we can do to engage and consult with the community.
Thank you. We still have time for more questions. Do not see anything coming, so let's move on and we can go back later to ask question on TMT again. Okay, so our next speaker will be James Fanson. Jim is going to give us an update on the Giant Magellan Telescope. Jim, are you ready?
Yes, I am. Let me share my screen. Can you hear me?
Yes. We are seeing you, not the presentation.
See if I have the right file up now.
Yes, looks good. Thank you.
All right. Well, thank you very much, everyone. I'm going to give you an update on the status of the Giant Magellan Telescope. Just to remind you, the GMT partnership consists of a dozen scientific institutions and universities across the United States, South Korea, Australia, and Sao Paulo in Brazil. And the telescope is being built at the Las Campanas observatory site in Chile, which is in the southern end of the Atacama Desert. The financing of the observatory development is largely by cash donations from these institutions with a small amount of in-kind contribution. This last year, we also, though, importantly received a sub-award through AURA, funded by the National Science Foundation, of about $17.5 million directed towards maturing technologies to achieve the full diffraction limit of the Giant Magellan Telescope. I'll try to point out the areas where that funding is being spent as I go through this. Again, to remind you, the Giant Magellan Telescope is a 25-meter doubly segmented aplanatic Gregorian design. The final focal ratio is about f8.2, and it operates, designed to operate from about 0.32 microns out to 25 microns. And importantly, it is built or designed to have built-in adaptive optics in both ground layer AO modes and for diffraction limited performance in narrow fields. This figure on the left shows you the optical surfaces. You can see the doubly segmented nature, the segmented primary mirror and the segmented secondary mirror. Primary mirror consists of 7 8.4 meter diameter mirror segments that are manufactured at the Richard F. Karras Laboratory at the University of Arizona. And the secondary mirror consists of 7 1.1 meter mirror segments, and we intend to manufacture 2 varieties of secondary mirror assembly. The first to consist of fast steering mirrors for tip tilt correction of wind shake for the natural seeing modes, and then adaptive mirrors, which would be basically 4th generation adaptive mirrors from Ad Optica that would be used for the adaptive optics and phasing of the telescope. The primary mirror status, we have now completed 2 primary mirror segments, 2 off-axis segments. The photo on the left shows the segment number 2 being placed in storage alongside segment number 1 in their transport containers. So these are awaiting shipment to Chile for integration on the telescope when the time comes. On the right is the front surface polishing underway for segment number 3. We've currently achieved 200 nanometer RMS surface figure accuracy. There are several months of polishing yet to be done to complete segment 3. Segment 5 is being shown on the left of this slide. You can see the rear surface where the load spreaders are bonded onto the back surface of the mirror. And this mirror is now awaiting the access to the grinding machine, as is segment 4, the center segment that has the hole in the center. On the right-hand side is the mold in preparation for casting segment 6. The mold is now complete, and we're scheduling the high temperature portion of the casting of this segment for March of this year. Segment 7 will either be cast later this year or possibly next year. Primary mirrors of this nature require a somewhat sophisticated control system, and we are, because of the segmented nature of GMT, we have additional requirements on the control components for the primary mirror. And so we are developing a test bed and qualification unit full scale. And you can see on the left-hand side is an exploded view, or a section view rather, that shows the various components that go into controlling the primary mirror. We have to control their rigid body orientation and position. We have about 165 actuators to control the surface figure shape. And of course, we have a temperature control system as well. On the right-hand side, you can see this test bed taking shape at the Mirror Lab at University of Arizona. We have a full-scale weldment, which we're about to begin to populate and integrate with the control components. Testing will begin with a steel mirror simulator, which you see the gray object on top of the white mirror cells, weldment. And then we'll progress to testing with a completed glass segment onto the optical test tower at the NOIRLab to verify our ability to achieve mirror surface control. At the secondary mirror, we've been concentrating on the adaptive secondary mirrors, and we've completed now a subscale prototype. The photos on the left, you can see in the upper photo here is the 2 millimeter thick zero Dewar face sheet in the coating chamber. And in this figure, you can see the zero Dewar reference body and the cold plate. So this subscale prototype has been under testing. And on the right is the full production adaptive secondary mirror with a 6-axis, 6 degree of freedom positioner assembly and exploded view. And we are about to begin the fabrication of the first of the off-axis adaptive secondary mirrors. These are being produced by Ad Optica, and this is where some of the subaward funded by the NSF is being spent. I should have mentioned on the previous slide, the integration of our primary mirror test cell is also part of the subaward scope of work. The telescope structure is on fixed price contract to OHB in Germany and Ingersoll Machine Tools in Illinois. It's a 3 degree of freedom structure. There's the conventional azimuth degree of freedom and elevation degrees of freedom. These are hydrostatic bearings. And then in the center of the telescope, we have a 3rd degree of freedom, which is a 6 by 9 meter cylinder, which houses the scientific instruments and the wavefront sensing and control elements. And this cylinder rotates to derotate image motion as the telescope tracks on the sky. So this is in design. We're about to have the industry preliminary design review and then proceed with long lead procurement and fabrication of the azimuth assembly. Our acquisition guide and wavefront sensing system is being developed by the Smithsonian Astrophysical Observatory. It's completed its final design review, and we're prototyping this assembly now as part of a test bed that I will show you on the next slide. This is a fairly complex device. There are 4 of these assemblies that involve a deployable probe and on a rotation stage. So these probes patrol in the field of view of the telescope and use guide stars for phasing and wavefront control. Also using the subaward funding, we're developing 2 test beds to validate the adaptive optics and phasing strategy in both the wide field observing modes and in the diffraction limited high contrast AO observing modes. On the left is the wide field phasing test bed that will make use of the prototyped acquisition guiding and wavefront sensing system. And on the right is the high contrast test bed, which needs a very high order deformable mirror. And so we're going to be marrying a telescope simulator with the MAGO AOX instrument, which was developed at the University of Arizona and makes periodic trips out to the Magellan observatories at Las Campanas and then returns to Arizona. So on its return periods in Arizona, we'll be doing testing in this testbed configuration.
Jim, you have 1 minute left.
Thank you. Our instruments are in various stages of development. I'm not going to go into any detail except to say that the first light instrument, the high resolution visible light as shell spectrograph, is completed final design of the spectrograph and is in long lead procurement of components. We also envision a fiber front end to take advantage of the full field of view of the telescope, and this is being prototyped by AAO on the Schmidt telescope in Australia using the Starbug self-mobile fiber positioners. Down at the site, this is a visualization of what the observatory would look like at Las Campanas. We have completed the preliminary design of the enclosure, which is now in final design. And having a drone's eye view of the site at Las Campanas, you can see our two support sites where we have housing for all of our staff and construction crew, the technical site. This is the summit. This is the highest point at the observatory, and in the background, you can see Carnegie's Las Campanas Observatory. Then taking a closer look at the state of construction, we have completed the excavation for the foundations of both the telescope pier and the enclosure. And we are now in the very final stages of finishing the infrastructure. We're now connecting the water system to the permanent water infrastructure at the site and tying the two water systems together between the GMT site and the Las Campanas site. So in summary, our design is maturing, our telescope structure is under contract, our primary mirror production is going well. We have various test beds and prototyping for risk reduction in place. Science instruments are maturing and our site construction has progressed through completion of the hard rock excavation, and we're ready for the next major portion of the construction project.
Thank you very much. So let's now have some time for question on the GMT project. And after we can, when we start our discussion, we can go back with community engagement and education effort. But right now, let's focus on any question on the GIM presentation. I do not see anything in the Slack channel. Oh, I have a question from Justin Spilker. He's asking, what about instrumentation? Any status for the status for the instrument? Any testing going on or things like that?
Yes, I went through that rather fast. So our first light instrument, the visible light as shell, has finished the final design review about a year ago for the spectrograph, and we're about to have the final design review for the front end. And we're in long lead procurement of lenses and fabrication. So that instrument's very mature. The other instruments are either in preliminary design or conceptual design with a focus on long lead procurement and fabrication. For example, for the GMT NIRS instrument with the silicon immersion gratings, we have continued to manufacture those to demonstrate that they can be produced, and there are other prototyping and other technology maturation work going on in the other instruments, but the other instruments are at a lower level of readiness in their production.
Thank you. Okay, so I think let's thank all our speakers. Thank you very much, everybody. And we're going to start as our discussion session. So let's start with the question from Tane. So if anybody from GMT would like to give a quick update on what are the efforts right now for engaging the local communities and especially on education.
So I can speak for the Giant Magellan Telescope. Outside of the context of the US ELTs, the NOIRLab would be able to speak to that. So GMTO for quite some time has had a leading role among the observatories in Chile in the area of education and inclusive astronomy. And in 2019, we partnered with EcoScience Foundation, Kavli Foundation, the Embassy of the United States in Chile to fund a mobile astronomy lab, and that travels around Chile. As you know, Chile is a very long country. Many parts of Chile are quite remote. And so we bring astronomy to these remote and underserved communities. So we visited a number of schools and a science fair in Santiago. And our intention is to continue that process and bring astronomy out to communities that wouldn't otherwise be able to have direct contact. In terms of, I think the other part of the question was local access. Because the observatory is located in Chile, Chile will have 10% of the observing time on the telescope to award as appropriate through their time allocation process.
Thank you, Jim. So I saw that also Jason Shu, thanks Jason, gave let us know that they will have a session 514 on education and public engagement, and TMT should be able there to give some update also. So if you're interested in the subject, please be sure to go to this session number 514.
Thank you, Jason.
Marie, I think there was a question by Alex Witz that you missed.
Alex. Oh, I do not see this question. Is it in our Splinter?
No, I think Marie did relay that one earlier. That was about the time frame for a decision to be made for
yes.
the TMT
Oh,
site.
and yes.
Feng Shuan did comment on that.
We covered that. Thank you.
Yeah.
Actually, I'm just going to, for those who are not members of the Slack channel, I'm just going to share that slide again in case you want to ask questions through Slack. If I can find it. Of course, I've lost it.
I can display it if you'd like, Mark.
Here we go. Sorry, got it. Yes, there's the Slack channel. So if you haven't signed into the Slack channel, you can do that now. It's kind of long.
Yes. Also, if you are shy, some of us will stay after the session, so you can ask question there too, or follow up on anything. And
in particular, I'd like to just invite anyone here at the session or anyone at the AAS meeting to visit the USELT program booth in the interactive exhibit hall. After this session, a number of us will be there at the booth from NOIRLab, TMT, and GMT. You can come and chat with us. You can come and Zoom with us. You can come and Slack with us. There are so many ways that you can talk to us through these interactive booths, but we'll be there right after this session to talk. Or you can come by sometime tomorrow. So you can see some of the information and documents and videos and things that we have posted there. You can get an exciting screen background like this one.
Thanks, Mark. Oh, so I think Warren is asking what needs does NOIRLab has right now in the project, in particular for US community input in the next 12 months. Mark, can you comment on that?
Sure, I'll comment on that. As I described, we're in the development phase now, and we thank the National Science Foundation for an award that they have provided to Aura and to NOIRLab to support that development effort. So that's been great. It's allowing us to get more people on board in our USELT program staff. That includes system engineers and software architect staff who are now beginning to scope out and work with TMT and GMT just how these systems would be built and how they will interface with TMT and GMT. In the meanwhile, on the science side, Marie and I and others at NOIRLab are starting to work on the science requirements for the various user support systems that I described in my presentation. I described them here at a very conceptual level, but we're now getting into the formal process of setting up the use cases that will drive the requirements for these systems. We've been talking, of course, with people at TMT and GMT about that, but we want to talk with you about that as well. And so if this had been, oh, you know, a year ago or so, I would have told you, look for a workshop that we'll be hosting sometime in Tucson. We did a couple about in 2018, we had a very successful community workshop for the Key Science Program concept development. Many people attended that, some of you attended that, and helped us with scoping out large science programs with TMT and GMT. That have been very helpful to us in terms of planning our user support systems. We would have had a workshop on community input on the science requirements, but we'll do something else. I'm not quite sure what the format will be. So we'll figure that out in the coming months and let you know. But there will be opportunities for people to participate and give us your feedback. And in particular, we're looking for experts in areas that that some of us are not experts. There are science applications for using TMT and GMT where I'm not an expert, and that we want help. We want your help in building the use cases that we'll want to be supporting in the future.
Thank you.
I also have a comment for that. We'd also, in the near future, when I have a postdoc on board, we will be reaching out to various folks about collaboratory practices that I know about in the community. But if you have a particular collaboration that is doing something innovative or interesting, or even just wants to share with us what you're doing around collaboration, please do contact me.
Thank you, Dara. So Pat, I think you have a question on the common technology. Feel free to speak up.
I just thought it might be interesting to ask Jim and Feng Xuan, is there some technology that's in common to the two projects that is either needs further development or is at risk, and in which a common investment, either from the projects or with the help of some federal agency, could reduce risks in the project and perhaps reduce risk for other areas in astronomy? And I'm thinking about perhaps large grading arrays or even detectors, since we've heard some experts at this meeting say that, well, CCDs are going away, the dinosaurs, and CMOS is the future, and all of our instruments that people are looking at require large CCD arrays. So I'm just thinking, are there ways in which the projects might come together and address common technical needs?
Yes, I will go first, and I typed in some answers, and Jim and I actually over the holidays are talking about exactly this same item, more ways to collaborate. And so far, last couple of years, we have collaborated and shared in areas such as laser metrology, refrigerants, and cryogenic subsystems. But clearly, the areas you described, particularly in the instrumentation area, I'm aware of discussion between WFOS and their counterparts in GMT, but there's certainly more ways to explore. Thanks.
Right.
I have very little to add to what Feng Xuan just mentioned, but we are in early discussions about what we might do on focal plane technologies, or looking at possible block buys. So I think we'll continue those discussions and try to firm up ideas where we could collaborate in the spirit of win-win efficiencies.
Yeah, and George Jacoby just added a comment here, which is absolutely true. I forgot that part of the instrumentation or even telescope optics discussion, we're looking at ways to enhance the UV coating, UV enhanced coating. So that's common interest for both.
Thank
you.
you.
I think that's something that we should really make sure we continue. If there's any way we can help with those dialogues, because Now that we're really looking at this in a system approach and the two projects are getting along so great and you and Jim have such a great relationship, I just think there's real opportunities for all of us to benefit from cooperation and collaboration here.
And we'll take on that patent and we'll come back to you.
Right. Just don't ask me for money, but you can come back and see what we can do. Yeah.
We might. Thank
Great.
you.
Thank you.
And thank
We
you,
have-
George, for that added input. That's really helpful.
Yeah, thank you. We have a question from John Tobin. He's asking about the timescale for the mid-infrared instrumentation on both ELTs.
I don't know if anyone wants to take that. I can just mention that GMT has an early light high resolution spectrograph that extends to 5.3 microns as the GMT nears. And so there is one early light thermal infrared instrument on GMT.
Yes, I think for instruments, beyond 5 microns, Rebecca Bernstein, our chief scientist, who's with us as well, is probably in a better position to answer the status of the next suite of instruments. And so I would invite her to type something into the Slack channel on that.
Or I don't know, Stacy, our support person, if you can unmute Rebecca Bernstein.
Hi, this is Rebecca. It is probably premature to try to think about second generation instruments, but Mark's answer was precisely right about our first generation instruments.
Thank you, Rebecca.
And there are certainly people thinking about concepts for future generation instruments for TMT as well. If you were at Chris Packham's talk, you heard about a lot of exciting thermal infrared science, and he's involved in a team for an instrument known as MICI that is a concept for a future generation thermal infrared instrument for TMT. But at the moment, there's no early light thermal light capability for thermal infrared capability for TMT.
Yeah,
maybe I don't know, perhaps Warren Skidmore or someone.
Yeah, I'll just add this to finish one that other than Michi that Mark just mentioned, we also have a concept for early decade instrument is to expand the modus capability to IR or mid-IR wavelengths, and the instrument is called PSI. And Warren, do you want to add anything?
Stacy, if you could unmute Warren Skidmore.
I can unmute myself, I think.
Oh, okay. Oh, sorry. I thought it was magic required.
I don't know. Yeah. So Michi has been in TMT. There's been a long heritage of mid-infrared ideas, and at the moment they've culminated in the Michi instrument, and this is it's not formally on the path to development. We have our 3 first light instruments which have been developed, and Michi is poised in the wings, ready as one of the first decade instruments, that kind of time scale. And because we don't have a strict roadmap for TMT instrumentation, it's more a responsive thing. We can't be specific about timescales, but Michi with, and Chris can tell me if I'm wrong, with some sort of IFU capability, high resolution spectroscopy, and an imaging mode as well. That's there's something in the works for TMT in the not too distant future after first light.
Okay, thank you. I think we have something like 2 minutes left, and I think there is one question still in the Slack. There was Grant Hill. He's asking about the need for environmental impact survey, probably when NSF become a partner, since it will be a federal agency.
Yes, I
specific?
can answer that. This is Finch one. Yes, we understand there is a need to do federal EIS if NSF is involved. And what we're trying to do is wait for that process to complete, or at least to certain stage before we start construction, rather than, we want to do it right. We don't want to rush this.
Okay, thank you.
Thank you.
So 1 minute left. Mark, do you want to have some final closing words?
Just to thank everyone so much for joining us, and it's been wonderful to have you here. Keep an eye on the Slack channel afterwards. There may be some more Q&A responses typed into there. But I want to thank all of our speakers. I want to thank Marie for keeping us all in order. That was very, very kind of you. And please do drop by our booth, come by and chat. And keep your eyes on the newsletters and your ears open for more news about the USCLT program and the NOIRLab newsletters and opportunities to get involved.
Thank you, Mark. Thanks, everyone.
Thank you, Marie, for great job moderating.
Yeah, thanks, Marie.
Thanks,
Thanks.
Marie.